What's up, guys? Welcome back to Vanover Machine and Repair, and welcome back to the brand new Lion lathe project. Now, if you've been following along, we bought this brand new machine, paid a ton of money for it, and then realized we basically had to rebuild this thing. Now, all jokes aside, the machine is going to be an excellent piece of equipment, and I've been really happy with the customer service that I've gotten from Lion themselves. But the machine build quality is not up to the Vanover machine standards. So what do we do around here? We make it right and we bring it up to the standard that we like to keep. And today's video, we're going to be doing some scraping on this brand new machine so we can get it dimensionally accurate as it should be from the factory. Now, Daniel is going to be coming over in a minute and we're going to start to disassemble the cross slide, take off the compound, and get the top piece off the apron. But before we do that, we're going to remove the backsplash and get this area prepared so that he can do what he needs to do. So let's get started by removing the backsplash. We got everything mostly torn down and we're ready for Daniel to come out. Hopefully we can buzz out these couple of large bolts and then pull this off. Daniel will take it over to his shop and get the top slide and the cross slide fitted together. And then once he's done, he'll bring it back over here and get the bottom scraped in to match the bed. Now, since we have it apart, I want to take a moment and just talk about, from a 10,000 foot view, why we're even doing this. Most people would just kind of let it be. And there are two main reasons. The first is that when you have a precision tool, you really want both surfaces to fit up nicely. That's going to allow you to run everything as tight as possible, minimizing chatter, and also that tight fit up and nice fit will minimize the wear on the machine and allow it to wear more evenly. Now, we've only had this machine for about 3.5 or 4 months, and the back side of the way is severely scored up. Honestly, when I got the machine, I had some problems with some grinding in this kind of motion here. So we took it apart, and at that point is when I noticed that we had some lines already kind of gouged in. And since that time, I've used the machine maybe a month, month and a half more, and the lines have doubled. They've gotten way, way worse. They look almost as bad as what we have on the pacemaker. And the reason for that is because the fit up is so poor on the top slide, debris is able to get in, and it's able to grind in there and wear way prematurely. So I'm gonna give you some close-up shots, and we're just gonna kind of use this knife blade to show you how the blade catches in these divots and show you how bad the damage is. And I'm really glad we're able to get this addressed now so we can prevent this from getting any worse. All right, I don't know how hard or easy this is gonna be able to see, but we have a knife blade here. All right, that's in the flat position, but I can actually take this knife blade and I can get it in this crack here and wiggle it around, and it's not moving because the blade is actually held in this gouge right here at the end. It's pretty bad. See that gouge right there? So as a control, this area over here is smooth, right? When I drag the blade across, see it makes a tiny scratch, which is not a problem here. But it easily drags across, right? Over here, it gets caught, right? So you can kind of see there's a pretty severe gouge right here. I wonder if I can run up it. There we go. So see how the knife sort of falls in this groove here? So this is a groove that's, I don't know, about 30 thousandths, 20 thousandths deep, and you can catch it with the knife. And we have these grooves. This groove here runs the whole length of this top slide here, or cross slide, and it gets worse at the back and it's better at the front. Our nail catches it easily, and if, for a comparison, come over here, nothing. Don't catch anything. So this side's pretty smooth, right? This side is very scored up. And that is very typical of a machine that's like 20, 30 years old, not typical of a machine that's 3 months old. And this aggressive groove here wasn't this bad a month ago. So this happened within the last month. And this is on the back side of the machine. So when you're machining, most of the debris is actually gonna catch and go on the front. So this is not good. So hopefully that's kind of obvious what's going on here, and hopefully by getting this scraped in, we'll remedy any problems like this from happening in the future.
All right, so I'm back here in Kyle's shop, tearing this thing apart, about to scrape it all in. Before we do that, I wanted to check the square from the master side on this dove, the perpendicularity of that to the bed. So right now, we have a master square that we're tramming in right now. So we have it set up where I'm gonna indicate this surface in parallel with the direction of the bed. So we have that 0, so we know that this plane is parallel with the bed. And so I'm gonna move the indicator on the top slide and check to see how square this is off of this edge, because we know that this is perfectly square because it's been qualified on a CMM. So if this is perfectly square and this edge and this plane is parallel with the direction of the bed, then this will show us how out of square this dovetail is from the direction of the bed.
And what do we want in terms of squareness? Don't we want it to kind of come in just slightly, like 5/10? Like you don't want it to cut it around, right, on the end? You want it to dish just slightly?
Yeah, I mean, you want it to be square.
Square, pretty much? Okay.
Yeah, because like in an ideal world where you have this machine bolted to like 2 feet or 3 feet of concrete. If you leveled this and bolted it to the ground, and then this was scraped as this machine is in its like final resting place, it should stay pretty close to being square.
Okay.
It's not an ideal world, so it's sitting on a bunch of levelers on a few different pads of concrete. Not the end of the world, but we're gonna just see how close it is right now, because that's important to me, because when I pull this off and start scraping it, I don't wanna just be aimlessly scraping material out of either side of this dovetail, because that's gonna effectively change how square it is, and I could be messing that up as I'm scraping it in. So if I know that this is pretty good where it's at, then as I'm scraping it, I need to be super careful about bringing this whole surface back all at once, like dropping that one plane, just making it flat, as opposed to try to tip it, because if I know that it's 5/1000ths out right now, I'm gonna try to tip it in the right direction as I'm scraping it. And I'll do most of that work in my shop, and then we'll come back in the scenario that it's out of square. We'll have to scrape it into square here on the machine. So we're just trying to get a gauge on where it's at right now. The blade on this square is real thin and it flexes a little bit. We really should have like a big granite square. It would just be easier. So sometimes you have to like, shim this up and try to get it so that the indicator doesn't walk off of it, but we'll just see what's going on. So that looks like pretty much 0. Oh, see, it came off. So let me shim this up a little bit.
Danny had to readjust the straight edge here, so he's going to take another sweep and see how we land.
That looks like 0 to you?
Looks
From your
0 heavy.
Little,
Pretty close.
couple tenths.
Yep. Looks like young Daniel's right. About a 1/2 thou.
1/2,000, okay.
So it's good.
It's pretty good.
So squareness from factory, 1/2 thou. Pretty good.
Yeah.
Should give us what, a thou on a diameter on a machine part, which is fine.
Yeah. And it looks like it repeats, right? It goes back to 0.
Yep, it's
That's
repeating.
1/2 thou,
Yeah, it repeats.
0. What are you seeing on that?
I'm seeing a 1/2 thou bumping. So it'll go to 1 thou if you bump it.
Okay.
You're happy with that?
Yeah, it's not bad. I think honestly, more of an issue than that is the taper of the gib isn't right. So
Okay.
you'll start to see error in how far out that is in measurements like this when we're chasing tenths. You'll
Okay.
see that.
Cool.
So we'll say it's within a 1/2,000 of being square. That's pretty good.
Good.
So when I pull this apart and start scraping it, I could mess that up because I'm doing it at my
But
shop.
you'll fix it.
Yeah.
So it'll be good.
I'll probably scrape most of it, get everything mashed pretty well, come back, check it, and then
Adjust it if.
bump it around if I need to.
Cool.
So hopefully we don't have to. I love my life here at Vanover Customs.
I'm wondering if something weird's going on under these caps.
Yeah, I don't know. We'll see.
I'm guessing dowel pins. Freaking fat ones.
I took 2 of them out already.
Now there is an oil line, so we can't get too excited. You know what I mean?
Yeah.
Yeah, I think it's a banjo fitting on the other one. Like there's a banjo fitting from here coming to the pump.
So we got it apart and wasn't such a big deal. There's some electrical stuff. There was binders on the front and there's 2 gibs on the back, but they're not tapered gibs. They're just like adjustment screws. So if you could imagine this being bolted up underneath the saddle, and this is the gib and there's 2 adjustment screws. So that's how you set your clearance. So this gets bolted like that. These adjustment screws just push this gib in and out. Nothing real crazy going on as far as like fitments go with the gibs on this. So this will be relatively easy to dial in later when it all comes back together. And for now, what we're doing is just looking at it, seeing what's going on. And I don't know how much of this is going to come up on camera, but at least just visually, this looks a little bit like a hack job. That a lot of this, it doesn't look pretty. Like you can feel a lot of surface. Like I can feel a dip right here. Like I don't know what happened, but this is all like, it's not, you can see some scrape marks up in here, and most of this looks like it was ground. Like when castings are hard, when they're not like a nice pure gray cast iron, when there's like some impurities, or if it's just made up of different alloys, even though it's cast iron still, it can be pretty hard to scrape. And so the way you can deal with that if you don't want to grind it on a whey grinder is to quote unquote scrape it with a die grinder with an abrasive, like a zip disc, like a cutting disc. And that's what I've done in the past on like Bridgeport knees that are chromed. That's a relatively quick way to deal with scraping the top of the knee without whey grinding it. So that might have been what they did here. This surface might be hard, it might not be, it might just look like how it looks. But we won't know that until we glue this up to the bed, which we'll do probably closer to the end. I think we want to deal with a nice flat plane on the top. So I'm going to work on the top first, like top of the saddle first, and then match the top slide to the top of the saddle. And then once we know that all of this is good, all that geometry is good, we can glue this up and see what's going on the bottom.
All right, so we're over here at Daniel's shop and we're having him take a look at this so we can see where we're at with the top slide. And as you can see, we have the top of the apron over here on the surface plate. And I just want to be transparent with you guys. My goal here is not to bash anyone, but I want to provide real and honest data of how things really are, so that any of you guys that are watching who are thinking about buying one of these, or even Lion themselves as the manufacturer, they can see the actual state of the machines as they come brand new. Not many people have the opportunity to take their machines apart or want to actually inspect and double check the quality of the rebuild or build on these new machines. And in this case, we are going to be fixing it and making it right, and that gives us the ability to double check the work of the manufacturer and see sort of how they did in terms of the actual manufacturing of the lathe. So Daniel has it on the surface plate. He did some checks before I came over, and I'm going to kind of let Daniel take over and let us know where we're at with the top slide first.
We're looking at the top slide right here, and as you can see, there's some blue on the plate. We took a couple rubs just to see what was going on. I like to give it a couple taps on the corners to see if there's any twist in it. So right now I can tell it's hitting on all four corners. If I give it a little rotation, you can see that's a high point where it's pivoting, so I know that's a really high spot. And if I can tell it's pivoting over here. So I can tell these two corners are particularly high. Ideally, you would want it to hinge in the middle, about a third of the way in from the ends. So I can already tell that it's high on the ends without even looking at it. And I can tell that we're touching on all 4 points, because if it wasn't, we would hear a rocking. So it's touching on all 4 corners. It's high here and here, which is not promising, but the question is, how bad is it? And earlier I slid a 1,500 or a 2,000 feeler gauge in the middle on one of these sides. So I know there's about 2/1000 of an arc. And that's not necessarily wear, that's not necessarily over the entire distance, but in the middle section, there's 2/1000 of a gap. And I should say that I think part of the reason that Kyle wanted to take all this stuff apart, aside from masochistic curiosity, I think there was a real issue that he was having with this, and it was that the top of the saddle was getting scored up, which shouldn't be happening on a brand new machine. And the rate that it was getting scored up would have destroyed itself in a matter of maybe 2 years or so. So I think that was sort of the catalyst for him wanting to take it apart. And since taking it apart, we're like, okay, well, if we're gonna do this, let's really do this and see where it's all at. So right now we're checking alignment on this stuff, and we're gonna pull this off the plate, put it on the table, and we'll show you what the bearing looks like compared to what the bearing on a master straight edge looks like, just so we can get a comparison on what good bearing looks like versus bad bearing.
All right, we got this flipped over, and as you can see, we have blue on the bottom of the top slide. Daniel, kind of tell us what we're looking at here and how this looks overall.
Okay, so what we're looking at here is there's a really high spot right here on this outside edge. There's a really high spot right here on this inside edge. There's a little bit of bearing trickling in along this outside edge here, and it gets pretty high over on this side and really high on this inside edge. So like we were saying on the surface plate, all four corners are touching. And I'm guessing this was one of the really high spots because of how polished out it is. And this was one of the really high spots. So it's not good. This is not flat. And I think that's pretty clear. So just for a comparison, this is a master straight edge that I haven't scraped in a while, and we just blued it up to get an idea of what it looks like right now. And as you can see, the ends are high, so it's a little light in the middle. There's no bearing right in this one spot, but you can see it's flat, like it's touching all the way down. So there's individual points. They're not super tiny. Like you can see each spot of bearing. And I wouldn't use this as a master. I would pick this bearing in a little bit better before I would use it. So I would just rub it on the surface plate and scrape it like anything else. These take a really long time to pick in. And I'm not saying that this top slide should look like this straight edge. This is a master. Even though this isn't perfect, we need to get this closer to looking like this. We're not even in the ballpark with this top slide right now. If we can get this surface flat that shows bearing all the way up and down off of the surface plate, we'd be in good shape. And I should say that we're going to be using this top slide as a master to scrape the top of the saddle because this is longer.
There are some critical issues with the lack of contact, and what are those issues and why is this a problem?
Because lathes see a lot of abuse on this top slide, if there's any gap in here that introduces chips between these two mating surfaces, it just turns into a nightmare. And I think Kyle, that's my suspicion is right now, because there's 2000s gap in the middle, I'm guessing that stuff is creeping in here, and especially because he uses flood coolant, I'm guessing that really fine particulate is just like seeping in. And because these surfaces aren't mated, because there's a gap there, you're just asking for chips to creep in and just tear the surface up. And you can see a little bit of scoring on here, as is. It's mostly on the top of the saddle. But the other thing is, when you're feeding in, you know, your top slide is rarely all the way up to where your handle is, right? Your top slide is usually somewhere out here.
About midway through.
Right, so if your top slide is just, I think this was about 1 inch longer, so if your top slide is this long, but practically when it's being used, it's out here, well, these two bearing spots aren't doing anything out here.
Right.
So we don't know what's going on with the bearing on it right now as it's being used currently.
Right.
So like half of the top slide might be floating off of your machine.
And if it's a dip there, then it's not going to be tight.
And you don't know what it's doing.
Yeah.
And yeah, to your question of like usability, can you make good parts? Of course you can. You can make good parts on almost anything if you know what you're doing. We talk about like best practices, and we talk about manufacturing and how things should be and how we want them to be and how unrealistic it is to scrape this stuff in. And I have my own opinions about it, but I think that this being a new machine, this is not scraped in. None of this stuff is scraped in. And I think I have to take this very situationally as a rebuilder and say like, okay, this will take me probably just as long to scrape in a brand new machine as it did to scrape in Kyle's 60 or 80-year-old pacemaker. That was worn 15 thousandths, 20 thousandths.
Yeah.
This will probably take the same amount of time. And I'm not saying this is worn 15 thousandths, but I am saying because these surfaces aren't matched, we don't know what it looks like. We need to flatten that out and then match that to this. And that'll probably take a day to scrape in between the doves and the master and the flats. And this will probably take a full day to scrape in, I'm guessing.
The level that we're scraping this into would be minimum level that they would manufacture any lathe machine tool 30, 40 years ago. And at the end of the day, a lathe is a precision machine tool, and this is a very critical aspect of that. You have the spindle bearings, you have the bed, and you have this stuff. And this stuff all needs to be within reasonably close to give that precision.
I should say also, this scraping is not really practically scraping. Like this isn't really scraping for alignment. The scraping that's on this top slide right now is scraping just to break up this ground surface, because I can tell that these surfaces were not matched. The scraping on this is really big and kind of aggressive, and because there's no real bearing and we can tell that these flats aren't matched up, you know, these angles might be way off because they weren't matched ground. So this is the top of the saddle that's on the surface plate. The bottom of the saddle has two flats, and this is where the binders bolt up to. How do you describe the binders?
The binder keeps this apron top piece from lifting up under heavy cuts.
Right.
And you want a certain amount of clearance, maybe 5/10 or 1,000ths, so that way it doesn't bind when it's moving, but it also keeps the lathe apron from twisting and popping up under heavy tension, right?
Right, correct. And also your apron is bolted up under here, and that thing probably weighs 200 pounds at least. So this whole saddle would be tipping up like this if there weren't binders keeping it up against the bottom of the bed. And I remember seeing on yours, there was significantly more wear on these guys on the back than there was on the front. And that's because the weight of that whole thing wanted to pitch it forward as you're cutting.
Sure.
So I talk about binders because when I set this on the surface plate, I just set it on these flats. It's kind of weird. It was sort of weird looking to me, but half of this binder was surface ground and the other half was machined. And this side was just machined. So, and when I set it on here, you know, I did that same test where I was knocking on each corner to see what was going on. Man, this thing was just rocking around like crazy. And I was like, whoa, I can't even measure off of this. That means that the bottom of this saddle, excuse me, is not flat. And
how much was it twisted by?
Maybe 10 thousandths. And that only matters so much as the binders aren't gonna be set in the same way. Like the clearances will just be different. And that's kind of okay because it's not one piece, it's actually four different
pieces.
Yeah, 4 different little pucks. Just for a comparison, like on your pacemaker, I had this set up in the same way, except this edge was pretty flat. And I think it was actually scraped in. So I think the face, because there was a gib, right? It was gibbed, there wasn't a binder.
Yep.
So I think this was scraped pretty flat, and I could sit it on this whole edge, and then I had a jack stand on one side, so I could kick it up and indicate these 4 points in off of the plate.
Make a plane of 3 points. One solid point and then 1 point in the front.
Which is effectively what I'm doing right now, except accommodating the twist by just shoving a shim in there. So is that something we're gonna deal with down the line? Maybe, maybe not. We might just leave the binders as it is because they're in 4 pieces. Indicating this in was trickier because we're sitting on this corner, a shim right here, and this point. And we don't know what's happening from the bed. The relationship of the bed to this surface is still unknown in this scenario. Whereas if we knew that the binders were parallel with the ways, or at least machined in a way that was pretty close, then we could assume that the surface plate that is projecting this plane that we're measuring off of, we're sort of simulating as the bed in
Right.
this like controlled scenario where I'm indicating off a master. This is as close to being parallel to the bed as we're going to get, and I'm trying to find a good reference to start from. So that's kind of what I'm setting up here is 3 points, this corner, and a jack stand. And so I indicated 0, 0 on this side, and I had a jack stand over here and indicated 0, and I had -2 over here.
So that's telling you, as the best you could set it up, you have a 2/1000 twist, let's say, and you would be hoping for what, like on a new machine?
2 3/10.
2 3/10. So this is what, 8 times worse than it needs to be?
Right.
Is this 2/1000 out and we have like 3/1000 of twist there? Does that produce a 5/1000 gap, or does it cancel out and only give you, a 1/1000 difference?
I think it really depends, because these parts, because that top slide cantilever is so far out, I think it really depends like where the top slide is in relationship to the saddle when it's actually being used. If there's 2/1000 gap right here, but this will actually be on this side, and if this is 2/1000 minus, am I actually going to have maybe 3 or 4/1000 gap? If this is just floating in space halfway off of your saddle?
Right,
Maybe.
right.
I don't really know. We'd have to set it up. And also, the other thing, talking about compounding issues, like the taper wasn't scraped in properly, so we know that there was a gap, a couple thousandths gap in the taper. So there was way more clearance on this thing than there needed to be, than there should be.
All of these thousandths of inch issues or errors or misalignment, they can compound and create practical problems like the scoring we've seen here, premature wear, instability under certain operations like boring, where
Right.
there's a lot of stick out and chatter. And that is why you want to see 0, 0. And that is why you want everything flat, because everything is a system. So each little bit of error comes together and produces a larger error. So the closer we get to 0, the better every piece of the puzzle is going to be, and the better the entire puzzle is going to be. All right, guys, we're going to let Daniel get to work, be here for 2 to 4 days, maybe working on this. So thanks, Daniel, for solving these problems and making this machine as good as it can be, and we'll catch back with you in a couple days. All right, Daniel's back in the shop, and it's been an interesting week. I was actually out sick while Daniel was working on this, so we didn't show you a ton of footage there. But Daniel's gonna bring us up to speed on what he ended up doing to get this to where we are today.
Yeah, happy to be back in Kyle's shop. Like he said, I was working on all the stuff at my place. I got the top of the saddle scraped in. I got the bottom of the top slide fitted to the saddle. I got the gib mogulised and refitted. So all the geometry from the top of the saddle up is good to go. Now, when I was setting all this up in my shop, I had the saddle on the surface plate and I had it sitting on the binders, and I indicated the top of the flats to the surface plate. And I was noticing that there was a twist in the actual saddle, and that was translating from the bottom of the binders to the top of the saddle. So there's a twist that started from the binders that translated to the geometry on the top slide. So this thing, there's 2 flat ways on the top here. This thing was kind of sitting like this, right? And so when I'm indicating that and I see that, I need to figure out, first of all, why that's there, how bad it is, if I need to adjust the twist on the binders or not, or if I just need to adjust the twist on the top of the saddle. And what I found out was the bottom of the saddle was twisted about 8 thousandths. I could slide an 8 thousandths feeler gauge. I think it was this corner was high, so it was actually like this. And so the geometry on the top actually reflected that. So it wasn't 8 thousandths, but on the top of the saddle, it was about 2 thousandths twist. It was 8 thousandths on the bottom, 2 thousandths twisted on the top. So I was thinking, you know, like these binders are independent. There's 4 pads. And so if there's a twist in the bottom of the saddle, it doesn't matter all that much because there's not a gib. If there was a gib on the binders, we would have to make that flat so that the gib as one piece in the back or the front could be adjusted with the right taper. But because they're just these pads like this, they can be adjusted independently with these little adjustment screws. So these pads just float on each corner. So I was like, you know, we could get away with not scraping the binders or having to regrind the binders, but we do need to make the top of the saddle right. I ended up scraping out about 2 thousandths on the top of the saddle. The dovetails were pretty good, but they were still out about 1.5 thou. So I scraped about 1.5 thou out of the parallelism of the dovetails on the top of the saddle. And the bottom of the top slide, this is the top slide, the bottom of the top slide was nothing close to flat. We were touching just barely on all 4 corners. So I don't know how much I scraped out of that, but it was a lot. And as far as my process, I think there's a few ways you can go about working on parts like these. And the way that I chose to go about it this time, partially because the top slide is bigger than the saddle. A lot of cases the top slide is smaller, but in this case the top slide is bigger. So I scraped the flats on the bottom of the top slide to the surface plate. So that's like my flat plane, and I used these flats to glue up the top of the saddle, as opposed to using a straight edge on each flat on the top of the saddle and indicating it off of the surface plate, which is what I did on the pacemaker. It takes a lot longer to scrape because you're checking alignment a lot more frequently. So I opted to not do that, and I just scraped this flat and blued this up to it. So they were matched together. Usually when you're working on parts like these, you need to have some reference of what is flat and good to build from. Like a foundation, you have a good foundation, you build up from there. And as you stack parts and you stack geometry, you know, things are parallel and you build parallel off of that and you build square off of those. But when you have a part that's twisted from the bottom up, you either need to address it at the bottom and work up from there, or determine if that's going to be an issue. And what I chose to do was ignore the binders completely and just work on this surface. So from here up, this surface up, the geometry is great. Everything's fitted. And so what we're doing right now is seeing how good and or bad the bearing is from the bottom of the saddle to the bed.
All right, so the next thing we're checking over here is squareness. Now we did check this before Daniel started. The goal here is just to double check to make sure that what Daniel did didn't affect it negatively. So Daniel, if you wanna give that a slide and see, and I think we had like about 1/2 thou before.
Yeah, it was cutting in, it was concave 1/2 thou before. And right now it's the same reading, which is good. And so when we set this up on here and indicated this part of the square parallel with the bed, and so the perpendicularity is also 1/2 thou minus, so it's going in, the square is going in towards the chuck, which is good. So, and it's repeating, so we're getting the same measurement we were doing before. I was really careful to try to go straight down. And by straight down, I mean when I would glue up the master and scrape it, I wouldn't cut one side or just cut the other side. I would cut the whole thing evenly so that it would just bring that entire surface back to being flat. This was the only good geometry this machine had. And honestly, it's kind of a miracle that it was that good, because there was almost zero contact, like almost no bearing. The fact that it's still within half a thousand, I'm kind of surprised, honestly, because of how little bearing there was on this when I started. Now that there's good bearing and this gib is fitted properly, we're in good shape. We're gonna show you one other thing before we pull this off, because we noticed some movement from the saddle to the bed that we're gonna set up right now and show you what that is. All right, so we have the mag base set up on the top of the saddle, and we just put an indicator on the square. Could be put anywhere, but you see all that movement? It's kind of settling right there. So we call that 0. We could get about 1,000 movement out of it. So that qualitatively is showing me that there's movement. So that I already know there's not good bearing from this to from the bottom of the saddle to the bed. We could have predicted that, I think, judging by what we've seen so far, but we'll know for certain in about 2 minutes when we pull this off. So currently there's movement between the bottom of the saddle and the bed, and we're just gonna try to not scrape this as much as we can, because in the interest of time, but also in the interest of not changing everything that happens below the saddle. If we start lowering this saddle, there's a lot of mechanical stuff happening between where the apron meets it and where the feed shaft runs through the apron. Hopefully we can just pick in some bearing and have it touch all over. But I don't want to scrape a lot out of this, because it'll start to affect alignment of the screw in the feed shaft and everything else below it. See the gib. So, this is a steel gib, and it has Mowgli's on the back. I had to scrape so much material out of the saddle and the top side that when you go to slide the gib in, you run out of adjustment. I don't know how much exactly I had to scrape, but the gib was lost. It would slide all the way in, the gib screw would bottom out, and instead of making a new gib that's the right thickness, we take the old gib and instead of just shimming it on the back, because the issue with shimming is that you don't get the right taper if you just slide a shim in. So if the taper's off, then you'll just have the gib touching on one end or the other end, and it'll either wear more on this side or on this side. And then you have uneven wear. So the whole point of a gib is fitting it properly so that the taper is matched to the geometry that it's sitting in. So in order to use this gib and not have to start over, I scraped the front flat. So this is a flat plane, and I mixed up this stuff called Mowgli's. This stuff in particular is an epoxy putty, so it kind of sets up like a peanut butter viscosity. And it's a really great material to use. I really like using it. Easy to scrape, I'm a big fan of Mowgli's. Next time, we'll do a Mowgli's demo. I feel like that would be pretty useful to understand. But I Mowgli's the back. There's about 60 thousandths of Mowgli's on here, thick. So I actually machined a bunch of material off the back because you want a certain thickness of Mowgli's. So machine the back, scrape the front, Mowgli's this, and then scrape the taper in so that when it slides in, now we're back up to our maximum adjustment where it's flush with the front, you got a wiper on there, and you have however much adjustment on the gib. So I think it's a really great way to do it. It takes a little bit of time.
You're gonna pull the top slide now?
Gonna pull the top side. Man, look at that nice scraping job. Dang, looks pretty.
It does look pretty. I see you did some flaking here too, huh?
Yep, scraped and flaked. Ready to rock. We scraped this flat, we flaked it. The reason we didn't flake the top of the saddle is because you don't want stuff sitting in those flaking marks and getting pulled underneath the top side. So we flaked the bottom of the top side, and should work great for decades and decades for Kyle. I also noticed these oil grooves, these things were razor sharp. And usually, and when I say usually, I mean always, you want to deburr oil grooves, because when it's razor sharp, what do you think is going to happen? It's just going to start cutting up whatever it's riding on. So,
Which it was.
which it most definitely was. So we deburred that, scraped it, flaked it. It's great. It's perfect.
All right, Danny, so we're looking at our first blue up here. What are your thoughts?
Well, I have a few thoughts. The first one is I'm really glad that it's actually touching the bed in more spots than I would have thought. So I'm a little surprised that it's touching the bed. It's not good. It's really high in the middle on this side, which is where that rocking was that we were just checking with an indicator. So it's high in the middle. The scraping looks pretty bad. And there's one high point here and a couple high points over here. It's a pretty good starting place. So that being...
The beginning is a good starting place, isn't it?
Starting from the top is not a bad place to start. At least we're not starting from it being thrashed, or I don't know. I think it's just like everything else that we saw, like very bad, and we're just gonna make it better.
All right, Daniel's been working at this for, what do you think, 6-7 hours?
Yeah, somewhere around there. We are at a lot better place than we started. And as you can see, there's pretty good bearing all over this, the V side. I cut the center out from about here to here. So bearing is super light right in the middle there, and pretty good bearing, or pretty good contact all the way across on the V, which is great. This side, there's pretty good bearing right up until, these few inches here. I cut some of the middle out, and there's a little bit of bearing on this side. And man, they took a grinder to this thing, and we're not gonna get any of this to come in. So this is all super low. There's a couple little spots in there, but after 7 hours of cutting all these surfaces back, the V came in pretty quick. And we would just, it'll take me another day or two to scrape just this flat in. So we have pretty good contact on this side. We know it's touching over there. And again, the V is good. So I'm gonna call it.
All right, we're just about ready to get the top of the saddle on. We got this all cleaned up on the apron, so I'm gonna go ahead and get that RTV. Got our wiring harness passed through, and I'll go ahead and get these guys mated together.
So I guess you got plenty of room with that apron lower like that. I guess that's kind of nice. A little bit of Earl. Oh, yeah.
Get that gib slid in. Daniel's setting the gib. He's got an indicator set up, and he's seeing how much deflection the cross slide has, and then adjusting the gib in to get to his desired number, which is what, about 1 thou?
Could be a half thou. We're at like
Thou?
7 or 8 tenths right now, so we could leave it there.
So we're close.
Pretty close. Check the back and make sure it's pretty much right there.
And he's checking the back as well, just to confirm that his angle is correct. So if he did a bad job, he would see like 3 thou. You know?
That's right.
But if you did a good job, it's going to be the same number as the front, or very, very close.
Huh. 6 thousandths.
Are you serious?
No, 7 8 tenths.
Oh, there it is.
I'm just kidding.
Pretty much perfect.
I'm just kidding.
Well, we got the cross slide back on, and we're pretty much done for this step. I got some work I need to do with some of the modifications, but Daniel's job is complete. What do you think, Daniel? How do we finish out here?
I think we finished strong. I think Kyle got a nice new machine again. I think it had a lot of issues, a lot more issues than maybe we thought. And I think the deeper we were getting into it, the more stuff we were finding, which is kind of the nature of the beast when you actually are like getting into like the technical side of this stuff. There was a lot of scraping we had to do for a brand new machine. I was a little bit disappointed. I was very disappointed in the amount of work that I had on my plate. But I'm happy to do it because that's what I do. And Kyle has a great operational machine that has way better alignment, way better bearing. I think it's gonna feel a lot better to actually use. I think it's gonna wear in really well and last a lot longer. So overall, I think it turned out really nice. It was a lot of work for both of us. We found a lot of things that were wrong the deeper we went, but it is what it is, and we just addressed it as we went along. And so here we are, and it's maybe, I don't know, 30 hours, 35 hours total of work.
Yeah.
So.
Just over here in this section, obviously.
Yeah. Yeah, so, I mean, I'm happy with it. I think Kyle's pretty happy with it too.
Yeah.
So I'd be curious to see, as he uses it, what it feels like and if he notices a difference in the usability of it.
Thank you, Daniel, for your help. I mean, this was a big deal for me. This is a big purchase, and to know that it's done right. I operated the cross slide and I was shocked. It operates, you know, basically the second smoothest cross slide in the shop next to the other Lion, but that one's turkided, so that makes sense. That's a little smoother. Super smooth, super nice, looks good, and I don't have to worry about this machine wearing out or scoring up, and I'm very happy about that. So Daniel will be back to work on more machines, so you'll be seeing him in the future episodes as we work on the other projects. So until next time, we will see you guys in the next one.
Thanks for having me.